the idea is that this is a project-based course, and it's all projects are interdisciplinary projects, something to do with computational, with something to do with biology. So the mix can be different. It can be different mix. It can be, a biological question answered using computational techniques, or it can be a computational question with applications to biology. So, for example, a program for automatic identification of zebras, individual zebras from photographs, it's a computational question fundamentally. How do you identify objects in a photograph, in an image? But it's applied to a specific domain of zebras, recognizing individual zebras, rather than face recognition or fingerprint recognition or something like that. On the other hand, so the project, maybe I should first so first of all, before then we get to the project, there was a website. So I should send you guys the website to the class. Oops, I should really not do this. Right. Okay. So there is a website. The class has a website. This is pictures from last class. There's some description, so you guys can get some idea of what's going to be going on. So in order for these projects to be interdisciplinary projects, we kind of have to get a common background. So we have to establish common vocabulary. Hopefully after today I'll convince you a little bit of what role computation plays in scientific research in general, in scientific exploration. And to be able to talk, we need common vocabulary, we need a little bit of common background and understanding of each other's domains, sort of the ecology and biology, more broadly biology and computation. And the type of techniques that are available in both, and the types of questions that are available in both fields. And that's what we're doing over this semester. Last time we did it in 3 days in Kenya, so this is what it looked like. So during the day, Dan was explaining ecology, giving a crash course in ecology, specifically tropical ecology. We would be driving around Impala for, I think, 7 hours a day, talking about the difference in different vegetation, down low, up high, the difference in the animals that would be in different places, where would zebras be found during the day, during the night, and stuff like that. And then in the evening, we would be talking about computation and various computational methodologies. So we figured 3 days is a little bit too short. So that's why we're doing it over the most of the fall semester, so to get a little bit of a better background. So this is very tentatively the topics that we're covering this semester. So the computer science students last week already got the introduction to population biology and ecology, and have most of the terminology and the concepts there. And today we're going to talk about computational thinking. That's this part. So maybe I should go to actual schedule. Right, so today we're going to talk about computational thinking as it's applied to ecology. And next week, Sanjeev Arora, who is from Princeton Computer Science Department, who is a computer science superstar, is going to, and he teaches a course in Princeton on computer science for non-computer scientists. So he's going to talk a little bit more about computer science for non-computer scientists. So you'll go more in depth about things like formalizing computational approaches to problem solving. And then over the course of the semester we'll talk about machine learning, which is statistical machine learning specifically, which is essentially agnostic, hypothesis-free statistical analysis, evolutionary game theory, agent-based modeling, network analysis, not necessarily in this order, but definitely on November 16th, because that's the only day that Ian can do it, collective decision making. And we'll talk about visualization. So another instructor in this course is faculty from Electronic Visualization Lab, Jason Lay. And we'll give you maybe a little bit of a virtual tour of EVL too. So we have several people from Electronic Visualization Lab. These are the people, so we are now in the space of Electronic Visualization Lab. This is it's a premier Electronic Visualization Lab in the world. These people, some of them are specifically these, and more sort of generally these people, the ones that are here, there are many rooms here behind us, developed virtual reality techniques, the cave, virtual reality cave, so the first one, and then today they're working on techniques of seeing 3D without glasses, just standing there and seeing the 3D landscape, for example, of Mars. They work with NASA on visualizing the NASA missions and deep Arctic explorations and deep ocean exploration missions. So they know how to work with scientists too. They also, one of the first projects that was done here by one of the founding members of the Electronic Visualization Lab, Tom DeFonte, who worked with people in movie industry and artists, real artists, was how many of you know Star Wars, the movies, right? Yeah. So Death Star was digitally developed here. It is cool. Right, okay, so we have some geeks there. Good. So these people, for example, EVL has a very personal relationship with Pixar and faculty. Jason just was at Pixar Studios, and they. You guys, when are you going to Adler Planetarium? Oh, you just went. Okay. So they developed also some of the sort of visualization mechanisms for the Chicago Adler Planetarium, and had a very personal invitation to visit the planetarium and things like that. So they're the right people to talk about visualization and how to visualize lots of scientific data. And we'll talk more in depth about past projects in the course and sort of the logistics of going there. What is Impala? What can you expect there? And over the December, you'll be working, hopefully you'll start thinking about joint projects. So each project, one of the conditions of this course is that each project has to have computational and biological component to it. So ideally each project has both a biologist, that's you, and a computer scientist. More than one, it looks like. Right. So over the course of the project, hopefully you'll be thinking already throughout the next 2 months about possible projects, possible questions, and the combinations of techniques and biological questions that can be done, but in a more focused way over December, we really start getting into teams and sort of proposing projects. So we also can think of what kind of equipment, what kind of stuff we need to take with us to Kenya, so we can hit the ground running. Because overall, we're going to be there 3 weeks total. That includes coming to Kenya, coming to Nairobi, getting to Impala, settling in, and going back. So each Nairobi to Impala and Impala to Nairobi takes a day, essentially. So we have just over 2 weeks of real work time to collect the data, do some preliminary analysis, and then do some data collection. Do you have any questions so far? They've heard the speech already, which is why I'm talking mostly to you guys. So, do you have any questions? No. You're just shocked because you thought you'd just taken truck topology.
I have a question.
Yes.
It says here on the schedule that on the 12th there is a class only in Princeton, so we are skipping that week, or we are attending to?
No, so next week it's going to be, so this is mostly for Princeton, yes.
Okay. But we are still meeting. We are still meeting here?
So it's going to be perhaps a brief meeting for us. This is going to be sort of just the overview introduction of computational thinking for non-computer scientists, right? So just like Princeton guys didn't have to be present during the whole ecology for for non-ecologists. I suggest, and this is purely suggestion, that you guys do come to the beginning, so there is common terminology, so you kind of know what they're, the stuff that you can expect from them to know.
Yeah, makes sense.
But in general, yes, this is next week is mostly for you guys. Okay. So also on the website, there's the wiki, which we're updating. This is leftovers from last time, but so you can see all the students kind of from last time. There were more biologists than computer scientists last time, but this time it's the other way around. And there's but we'll be working, so the main purpose of the wiki, and all of you will have access to it, is to start sort of working on projects. There will be project areas for each one. There's also the blog, which is right now blog from last time. So you can see all the fun part of last time. But we'll continue the same blog for this year. And sort of keeping track. From now on already, you guys can start, we'll give access to everybody. All lectures that we have video posted on the website. So there's already video from the introduction to ecology. You guys can see what was there last time, what they know, just like they will know what you know. I think this also is recorded, right? This one. So it is recorded. I will never look at it again myself. No, but so it is recorded. So maybe you guys don't have to go, but you can see the video from the recording. Any questions? Okay. So let's start then. What does computation have to do with ecology, and how does it all fit together? So normal scientific process, the way kind of it happens. You have a question that you have a burning desire to answer. For example, why do animals do what they do? It's not a very specific question, right? It's a very broad kind of question. And there are many possible ways that you can answer this question, right? But all scientific exploration starts with some curiosity. Why is the sky blue? Why do animals do what they do, right? Why do these, when I mix this stuff together, why do they go boom, right? So you can instantiate this question in many possible ways. And the ways you instantiate this depends on the available tools, your domain expertise. So if you ask this general question of why do animals do what they do, if I asked you guys, you as biologists, and if you would instantiate it in very different ways, right? You can ask, why do animals go